And so we're going to talk about error types today. And I sort of toss up about whether it's important for you to know which one's type 1 and type 2 and so on. And I'm not sure that that really is that important, but it is important for you to understand that there are two different types of error and that there's a trade-off. And so a way to make you do that is to actually know which one is which. So that's why you are tested on whether things are type 1 or type 2 error or if they're correct. Okay, so there are two things in states of nature. This is just an expression. Okay, so here, the null hypothesis is true. Okay, when I had my pinkies here, or pinkies, supposedly pinkies, Mars, and crunchies, I told you that 1/3 were pinkies and 1/3 were crunchies and 1/3 were Mars. So the null hypothesis was that the probability of a pinky equals 1/3. That was the null hypothesis. Even though you didn't think it, it was. Okay, the other way it could be is that the probability of a pinky, okay, it's not that it's 0 or that it's 1, is that it's not equal to 1/3. Okay, so we're not actually proving anything other than whether the number of pinkies in the bag was 1/3 or not. Okay, now, those are the two things that could be the case. This is the one that actually was the case. Okay, now, we can do two different things. We can reject the null hypothesis, or we can fail to reject the null hypothesis. And in 2 of the 4 combinations will be correct, and in 2 of them will be wrong. Okay, so if we say the null hypothesis isn't true, we reject it, and it really isn't true, then we're correct. Yay. Okay? If we say, no, we're not going to reject the null hypothesis, we haven't got evidence that it's false, and in fact it is true, then we're correct again. Yay. Okay. But if we decide to reject the null hypothesis and we say pinkies is not equal to 1/3, or the probability of pinkies is not equal to 1/3, but in fact they were 1/3 and we just happen to get a weird little sample, we would make a type 1 error. Or if we don't reject the null hypothesis, so we say, oh no, it's fine, we say that probability of pinkies is equal to 1/3, but in fact it isn't, then we make a type 2 error. Okay, now it's confusing, I know. There's a really easy way to do it, and there's these really complicated ways that I think other people teach you, but don't listen to them. Okay, when you're given a scenario, it's really clear whether they were correct or not. Okay, if they're correct, there's no error. If there was an error and they rejected the null hypothesis, then it's a type 1 error. If they didn't reject the null hypothesis, it's a type 2 error. So you don't have to think about, now, was it true, blah, blah, blah. You simply have to know, was there an error? And if there was an error, think, did they reject the null hypothesis? If they did, then it's a type 1 error. If they didn't reject the null hypothesis, then it's a type 2 error.